All right. So in this case, I need us to quickly work out this question. As we can see, it just seems to be direct, but there's some of the important things that we need to take note. We are given on question number two transverse pulses A and B approach a point P. Okay. In the same medium, pulse B is traveling to the left. All right. Take note, B is going to the left. So A will be going to the right. And he has an amplitude 3 times bigger than that of pulse A. 3 times bigger than. So meaning to say, if A has got 1, B has got 3, because it will be 1 times 3, 3 times. If A is 2, then B is going to be 2 times 3 because it's 3 times. What about if A is X? What about B? B is going to be 3X. That is the condition that we are given there. If A is X, B is going to be 3X, but they are saying B, the one that we are given, pulse B, is 3 times bigger than, 3 times larger than, 3 times. You multiply. All right? So whenever you're given a times, 3 times larger or 3 times bigger than this, you multiply, or maybe it is 5 times, whatever that you're given, you multiply. Then they're saying both pulses have a wavelength of 5 centimeters, A and B. They are the same wavelength. The pulses experience destructive interference at point P, where they form a trough. All right. So they are going to form a trough with an amplitude 6 centimeters. All right. There we are going to need, actually, for us to answer these questions, no problem. We're going to answer these questions, but I need us to understand something here before we answer these questions. Remember, we are told B is going to the left, meaning to say it is moving to the right, going to the left, B. Okay? Meaning A will be going to the right. That is the case of our question. And we are given that B is traveling, as it is going to the left, it has got 3 times larger than that of A. And both have got wavelength of 5 centimeters. Remember the condition when it is a destructive interference. All right. When you are dealing with a destructive interference, I said this is a condition whereby you'll be joining or whereby you'll be moving from a crest. You'll be joining a crest to what? To a trough. So you're going to be having a crest and a trough. It is different when you are working with a constructive, where you're working with a crest to a crest. This one, it is either a trough to a crest or a crest to a trough. So meaning to say that if A is like this, let's say this is where A was A, it will be going to the right. Remember, B is the one that is going to the left. So A will be having something like this, all right? Going to the what? To the right. Remember, they said A here, B is 3 times. So A is smaller than B, all right? A, this is where A is. A is smaller than B. A will be going to the right. Then for B, B is bigger than A, but they are going to form what? A destructive, where wherever a destructive is formed, it means before you had, if this one is having a crest, the other one is going to be having what? A trough. That is the condition. So B will be having a trough. That is the condition. And we are told that B is 3 times this one A. So meaning to say if A is X, all right? That is, we are told in terms of the amplitude in that case to say if that is X in terms of the amplitude here, if this is X, this one is going to be 3X. But take note, this is 3X in the negative. We are in this negative side. So we can refer to this one as negative 3x. This is the condition. As they are moving towards P, where they are going to have that disturbance, the destructive interference. So this is the condition. And as you can see, this one is having positive, this one is having a negative, and this is smaller than this one in terms of, it's just like we are given 1, then you add -3. You're going to have a negative at the end. So in this case, whatever that we are going to have after that destructive interference, that destructive interference, at that point of destructive interference, it is going to be in the negative. And the distance that we are given, which is the wavelength, as we are given, they are the same. We are given they've got the same wavelength, 5 centimeters. If this is 5 centimeters, this is also 5 centimeters. When they meet at that point of when they have the destructive interference at this point, they'll be having same wavelength. Then this is the sum. Remember, there you shall be considered to the sum when you add. We shall talk about that. But they told us that at that point, it has got an amplitude of 6. And remember of what I was explaining to say, this is smaller than this one. So definitely it's going to be in the negative. So meaning to say, the 6 that we are given as the amplitude there, it's -6 centimeters because of where it is. Yes, you write it as 6, but know that it is carrying what? It is carrying a negative. It's in the negative region. Just like this 3x, know that it carries a negative. So this is just our understanding of what we are given there. All right. Anyways, guys, let us answer our questions. Just hope it will help us answering these questions. On 2.1, you are given name and state the principle used to determine the resultant amplitude of the pulse formed at P. At P, the pulse that is formed at P here. Which principle is that you consider when you are talking about this destructive interference? You're talking about the superposition of what? Of pulses. The principle of superposition. That is the first thing. Name it. It is the principle of superposition. What does it state? The principle of superposition states that when two disturbances occupy the same space at the same time, the resulting disturbance is the sum of the two disturbances. The resulting is the sum. That is the case that you are being asked here. To name and to state it. All right? Then determine the amplitude of pulse B before, take note, before it reaches P. Before it reaches P here. Remember B at this point, we're calling it 3x from this condition. When it reaches the point P, before it reaches P, where we have got a destructive interference, it is now having an amplitude of 6, which is -6. So guys, we are saying from the superposition of pulses, this principle of superposition allows us to add these two, the amplitudes. It allows us to add these amplitudes. So why not using that principle to find x, which is the unknown? Because we know that this principle allows us to say the amplitude which is at A before plus the amplitude which is at B, take note it's in the negative region, so it will be minus like this, must be equal to the resultant, the sum. The principle is saying the addition of amplitudes supposed to occupy the same space at the same time, but you're supposed to make that addition. So what is that? When you add, you're going to obtain -6 because of it will be in the negative region. We have formed an equation. Solve for x. By solving for x, we can have this because we know that at B, it is 3x. So what is the value of x? Right? This is 1x. So it's plus or minus. That's a minus, guys. All right, which is -6. We are back to our equations. 1 minus 3. That's -2x is equal to -6 divided by -2 by -2. So x was going to be equal to 3. So x, if this here is x, meaning to say if this is 3 centimeters, remember this is in centimeters, so x is 3 centimeters. It means the amplitude here for B will be what? 3 times 3. So the amplitude at B will be equal to 3 times 3. Before it was 3x. So that is 3 times our x, which is 3, which is 9 centimeters, or you can write in meters by dividing by 100, which is 0.09 meters if you want. That is the condition there about the amplitude. So take note, the negative, you are using it in calculations, but when the question is asking you, what is the amplitude? You write the amplitude as a positive, just like how you're given here. They are saying when they experience this destructive interference at P, the amplitude is 6. They did not give you as -6. You are the one who is to write -6 on the calculations, but when you are referring to the amplitude, you just say the amplitude is 6 meters, 6 centimeters, depending on what you're given. Here we are given what? Centimeters. That is the condition of your question. All right. So let's consider another part. Write down the wavelength of the pulse at P. So at P, as we are given these wavelengths before, at A, it is 5, at B, so I said the same is going to affect our final answer, because this one is just addition. They will just combine at that point, having the same wavelength. So meaning to say it is going to remain as 5 centimeters as it is given before. On 2.4, you're now given to draw the pulses after they pass point P. Label each pulse clearly. As they pass the point P, remember at point P, that is where we have got our destructive interference. So what happens after? After pulses pass through each other, each pulse continues along its original direction. Each pulse continues along its original direction. And as they continue in their original direction, they remain, or they reframe their original amplitudes. So what does it mean? B was moving to the left. So at this point where we have got our destructive interference, B is going to continue to the left in its direction. It is going to continue where it was going. B is going to the left. So we are going to see B this side. A is going to continue. Where is A going? A is going to the right. They interfered here. A is going to continue to the right. So we are going to see A on this side. As they continue to with their directions, their original amplitudes remain unchanged. Their original, meaning say A will remain as it is before. So that is the condition of our question. So 2.4, our final answer was going to be like this. We are going to notice A is now this side. So this is where we have our A. All right. So A like this. And this is where we are going to be having our B. B will be on the left side. Remember, B was moving to the left. So we'll see B on the left side after interference. We'll see it now on the left side. So this will be our B. This is our A. Remember, B was the one that is more because it is 3 times what? 3 times X. So that is why we see B is bigger than A in terms of the amplitude. That is the condition. You can even write the amplitudes. It's up to you. That condition, guys, it's up to you. A is still moving. It is still going to the right. A is still going to the right. B is still moving, going where? To the left. That is the condition. So it reverses what is here, because this one is going there, this one is going there. But they will be back to their original amplitude. That is the most important part. So if this was 3x, which is, we say 3x is 9, it means the amplitude for this one, the amplitude there at B will be 9. Remember, we said 3 times 3, which is what? Which is 9 centimeters. What will be the amplitude at A? Remember, the amplitude of A is X, and X is what? 3 centimeters, meaning to say we've got an amplitude of 3 centimeters there. The wavelength is nothing is it's just as they were. So guys, just try to work out as many questions as you can, because the basics you have, all right, you have got your notes, the theory is there, the formulas, they are there. But can you use that information to answer typical exam questions? That is the most important part. So if you've got your notes like now, Do as many questions from now. Try to figure out how do they ask these typical questions. So that was it, guys. Let us add as many questions as we can.